What's up guys, assalamu alaikum, this is Puya. In this tutorial I'm going to talk about if statements, especially how to write an if statement, how to write if else and if-elif statements, what are scopes in Python, and what are the boolean values of different data types in Python. So without further ado, let's begin. So first, let's see what is the structure of if statement. To create an if statement, the structure is like you write down an if here first, and your condition. Your condition should return a boolean value, no matter what kind of comparison or a function or whatever. We're going to talk about function in the future videos. No matter what you use, the output should be a boolean value. Then you write down your statements. For example, what do you want to do if that condition is met? For example, if your value is 100 or if your value is 10, you want to do something, or you want to propose something to a group, you want to show something, you want to print something. In that case, if statements are very useful. We need to use if statements to change the flow of the code. For example, here, as an example, we say the value is 100, and we say if value is equal to 10. This is a comparison operator that we talked about. We talked about in the previous video about it. It says if val is equal to 10. So definitely the val is not equal to 10 because it's 100. If it's equal to 10, print this out. For example, print value of expression is 10. So let me run the code, and okay, let me clear the output so we would have a fresh experience of running the codes. Okay, there are no outputs here. So okay, let me run this still again, and as you can see, this part is not executed because the value is not equal to 10. So kind of the flow of code, the way that the code is run, did not enter this section, or does not enter it because the value is equal to 10. Is not equal to 10. Okay, let me put value, let me change value of val, and it is equal to 10 right now. And as you can see, value of expression of the upper expression is 10, and it prints this statement. You can have several lines of code or several statements after your print, after your if statement or your condition. Whenever your condition is met, these lines of code or statements are going to be executed. So what is the scope? As I told you, if a statement, the flow of code is changed by if a statement. Whenever the condition of if a statement is met, some codes are executed, and whenever it's not met, those codes are not. So how Python defines which lines of code or which block of code belongs to an if statement and which a block does not belong to it. If you're familiar with other types of programming languages, you might be familiar with curly brackets. The curly brackets are used in like C#, Java, C++ to define block of code for the exact preceding if or other types of statements that they need a block of code. These are used to define a part of code for the preceding, for example, if statement here. But in Python, we don't use curly brackets. So what do we use? Here, as you can see, I have just write down all my codes in a single, in a sequence, as you can see, after one another, and I'm gonna run the code. As you can see, it says indentation error. It said expected an indented block after if statement. Some group of statement like if a statement, with a statement, I mean while, and other group of uh, codes that they need a block, they need an indented block. What is indented? This is called indented block. This is the indentation, as you can see here. So after an if statement, you need to have an indented block. How to create an indented block? There are several ways. You can put tabs before your specific block. For example, in here we've got one line. In here, our block contains one line of code, so it has only one tab. If we had, like, for example, let me print out my name here. For example, my name is, yeah, whatever. I have two lines of code and I have two tabs, as you can see. You can have tabs, you can have 4 spaces, you can have 2 spaces as well. If I'm not mistaken, Colab by default uses 2 spaces, but Jupyter Notebook and PyCharm by default they have 4 spaces or a tab. So to create an indented block, you need one of these options. It's not arbitrary, it's not obligatory. You can, for example, have only one space. As you can see, there is one space here, and it doesn't return, it doesn't raise an error. But as you can see, it is printed in red block. Jupyter says, you know, it's not, it's against the convention. Whenever someone reads your code, they like to see, for example, a tab or 4 spaces. It makes reading the code easier for other programmers and for yourself as well. So let me bring it to the way it was. Oh, so we would have the indentation error. So to get rid of the indentation error, you need indented block, as I told you. And one thing here as a note is, like, whenever you write down your code and you put this colon, after colon, if you click on the enter button, Jupyter and other IDEs, they move your cursor by a tab or by 4 spaces or 2 spaces based on their defaults. They do it automatically because they know if they put the cursor here, whatever you do, you're going to face an indentation error. So by default, after colon, when you click on enter, you'll see your cursor will be shown after an indentation. And one more thing that I forgot to mention here, after conditions, you need a column. After your condition, if then your condition, you need to put a column. If you don't put a column, again, there will be other types of errors. So now let's talk about if and else statement. So consider that you have a condition in your if-else statement. You have a condition. Whenever it is met, you want your code to do some kind of stuff. And whenever it is not met, you want your code to do some other, to execute some other lines of code. For example, here, consider the height of a player is 2.2 meters and 2 centimeters, and you want to print out for for example, all the players in your team, in your class. For example, if a player's height is above 2 meters, you want to tell the guy, you know, you're a qualified person for a basketball player. And if it is not higher than 2, it means if it is lower or equal to 2, you want to say, you know, you should follow other sport fields. Okay, you're not, for example, qualified for basketball. This is something I made it up. Okay, it's not based on knowledge or whatever. If we want to do when a condition is not met, if we want to execute some lines of code, we use else. Else simply said, if this condition, the first condition, is not met, so I'm gonna be executed. My block is going to be executed like this. If this condition is not met, else comes in the middle and runs whatever that comes after else. So this is simply if and else statement. Whenever the first one is not met, the else will be executed. So what about you've got more than one condition, more than two conditions that you cannot handle it with just if and else? In that case, we use elif keyword. Elif keyword simply says if is not the condition of the first if is not met, okay, kernel, please check the second condition or the condition which is after elif. And again, if it's not condition, if its condition is not met, check the third condition and go on until all the elifs are checked. And if all the ifs and elifs conditions are checked, and they are not met, they're not satisfied, they all returned false, okay, in that case the else will be executed. Consider our last example. The height of program, the player program, the height of the player is 2.2 meters and 2 centimeters. If if their height is higher than, for example, 2, you tell the guy, okay, you are good, you will become a good basketball player. If their height is, for example, larger than 1.8, they are taller than 1.8, in that case you tell the guy you will become a good volleyball player. And that, other than these two conditions, you should follow the other fields. Let go of this field. You can have several elifs, not just one, not just two, as many elifs as you want. But if and else, you can have only one of these two. You can only have one of each of these two in your code, in your if, elif, and else statement. For example, you cannot have another if here. If you have another if here, it starts another if condition, if statement. If it starts another if statement with its own elif and else's. In that case, this one is allowed. Okay, so if you want to have a nested ifs together, you should have one if, several elifs, or just one elif, and just one else at the end. You can emit this one as well. So this is how nested if statements work. So let's talk about boolean value of different data types. So every object in Python has a boolean value. Whenever they are used as condition in here, they return a boolean value. So let's check some of them and let's see how we can use them in our codes. So here it says Python assumes any non-zero and non-none values as true. Well, kind of, that's a valid statement. And if it is either 0 or none, then it is assumed as false. So let's see, what does it mean? If your condition, whatever comes here, is equal to 0, it simply means false. This statement, this condition is equal to false, and the block which is under 0, under the condition which is equal to 0, is not executed. As you can see here, it says if 0 print impossible, else print 0 is false. As you can see, because 0 is false, this condition as a whole is false, and therefore this one is not going to be executed, and only the block of else is executed, and it returns 0 as false. Any non-zero numeric values are true. For example, this value is very, very close to 0, and it is negative as well, but it is non-zero. Simply, it is non-zero, so it is executed. As you can see, it is executed. Non-zero numeric values are true. It doesn't matter, you can put an else here as well. For example, print this is not going to be executed, or something like that. It doesn't matter whatever you put here, how many elifs you put here, because this condition as a whole is true, because it's non-zero numeric value. Then in that case, it's going to be executed, and as you can see, this line is executed and printed out. Non-zero numeric values are true. Let's continue. None. If a value is none, it is as if it is false. So if a value goes here as a condition, is used in this section, in this part of if a statement as condition, as a whole it means it's false because it's none. This is how Python views none and, for example, zero values. They view them as false. And here, let me run this. As you can see, this block is not executed, and this independent block is executed. It says none means false, and as you can see, this statement, this condition is not met, and the else is executed. So this part is executed. So okay, let's move on to other data types. Empty sequences. Empty sequences are by default false, no matter what. If you have an empty sequence, it is false. Well, let me put str here as well because it's a sequence data type as well. For example, as you can see, I have defined a variable here. Its name is empty sequence, and its value is equal to list or empty list, not just the list. It is equal to empty list, and as you can see, this condition is equal to false. This condition is not met, and therefore this part is not executed, and this block is executed. Empty sequence is equal to false. Doesn't matter. You can put here, for example, an empty like string. And still, here is that empty string. Is still the output is equal to false. Okay, let me bring it back to what it was, and for example, you can do this, use this too as well. They both are empty, therefore the Python consider them to be false. So how we can use them in code? For example, when you have a list, before accessing its items, its index, you want to make sure whether it is empty or not, because if it is empty and if you try to access its input, it's gonna raise index error, out of range index error. Huh? Was it like that? Let me check the error. I forgot it. Yeah, list index out of range index error. List index out of range. So you want to make sure that the item that the variable is not empty. In that case, you got two options. You can go like this, len lsd. You can how can I say? You can measure the number of items in your sequence data type by just counting the numbers using len, and check whether it is 0 or not. And here it says if it's not 0, execute these lines of code. If it's 0, then if the list is empty, do other types of code. This is one way you can do it, and this is the another way. I think this is much simpler compared to this one. You write less number of codes here. For example, you don't use len, you don't use this comparison, you don't use 0, and you just simply say if lsc. It simply means whether lsd is empty or not. In that case, you go on. If it's not empty, so run blah blah blah. If it's empty, run blah blah blah. That way you can use this features that Python has. One more thing that I forgot to mention here, in the previous video we said whenever you want to check whether a value is none or is not none, you can use is as well. I believe this one is more explicit, and I like to use this one in most of my code. Whenever I want to make sure a variable is not none or is none, I explicitly write it down. I say if val is none or if val is not none. You can use like this, if val, simply use like this, but I don't know, whatever. I like this one more. I like this one better because it's more explicit. So that's it for this session that we talked about if statement. I hope it was beneficial for you, and I encourage you guys to introduce these videos with your friends and colleagues. Please subscribe the channel and click on the bell button so you will be notified of the future videos. So thanks for watching. See you in the next video.